Hey everyone, I'm Nikhil, and today I'm going to present some joint work with Ramesh on designing informative rating systems. And we're going to do this in the context of a large online labor market. So at this point, I think most of us have probably used one or multiple of these rating systems on online platforms. And I show this on the screen just to emphasize that there's really a very large design space when it comes to designing online platforms, when it comes to designing rating systems, in terms of the question that you can ask, how many questions you ask, on what dimensions, what the answer choices are. Do people input text, or do people just pick out of one of many options? These are all design choices that the platform has to make. And in this paper, we hope to advocate for a principled design approach to make these choices. But the particular context that we look this in is online marketplaces, where basically, regardless of the design, it seems that historically most people are getting 5 stars most of the time. That the sort of rating information is really a problem that every platform has expressed that they struggle with, regardless of the context. And this seems to be a problem that is getting worse over time. And so one of the particular questions that we hope to answer is, are there design changes that tackle inflation in particular? And so as an overview of this work, at a high level, we hope to show that platforms can design the information that they obtain from people, and they can do this in a principled manner. And in particular, that they can yield deflated and more informative ratings in online marketplaces. And this has a two-pronged approach. The first one is needing to reason about how the platform design affects the information that you receive. And this is really an experimental question, connecting the rating system design, for example, the rating system question, to the answer distribution that you get. And this has to be an experimental one because really there's no theory that's precise enough to tell us how a particular rating question will perform on a particular platform. But then there's a second part of this question, which is, what is actually the rating distribution that the platform wants? How do you connect this rating distribution to something that the platform cares about? For example, how does it learn about participants better? And so this is a theoretical question, which is, how does the rating distribution affect how quickly the platform learns about participants? And I hope to tell you a little bit about each of these in this work, in this presentation. So at this point, I'm going to very quickly summarize past work. There's a lot of work on designing rating systems for platforms. Sort of the empirical literature documents that inflation is a huge problem on basically every platform. And then there's a few theoretical works that suggest how do we learn faster in these systems. And the first order lever that all of these works focus on is, how do we change who matches with who in order to learn about maybe rare participants better? In this work, we hope to focus on an orthogonal problem, which is, how do we maximize the information that we receive in each, from each participant during each rating instance? Okay, so let's start with our experiment. And this is where we hope to connect the platform design to the information that we receive to show that not everything is hopeless, that we actually can get deflated ratings in online marketplaces. So the status quo in this platform is that, the way that things work is that clients hire freelancers, and then at the end of a specific contract, which may last, a few weeks or however long, the client rates the freelancer in a fairly long feedback form. The feedback form includes a status quo numeric rating that goes from 0 to 10. And unsurprisingly, this is a very highly inflated rating. The average is over 8 out of 10. In this form. And then the challenge we have is, can we induce different, i.e. not inflated ratings, by changing the question that we ask on the rating form? Our experimental design is as follows. We add an additional question to the private feedback part of the rating form, and we have 6 different treatments that I'll describe in the next slide. We randomize at the client level, so a client may close many jobs over the 3-month period that we run the experiment, and they're going to see the same additional question every time they close a job. And so this prevents any contamination between the treatment cells. And then we let this experiment run over 3 months. We observe 180,000 jobs being closed by about 60,000 unique clients and about 80,000 unique freelancers. And there's many, and I'll sort of talk about how we leverage this later, but we actually see many repeat client-freelancer pairs in this data. Okay, so what are the treatment groups? The first one is a pseudo control, which is we add a new numeric question to the feedback form, which is phrased differently than all the existing questions. And it simply says, how would you rate this freelancer overall? And it goes from 0 to 5. And then we add a sequence of sort of other treatments. The first one has the same exact question, but all we do is we label the answers. So there's still 6 answer choices, but now we just label them with adjectives. And the key thing that we wanted to test is we wanted to test positive skewing the labels on the answer choices. And so the equivalent of 2 out of 5 is good. The equivalent of 3 out of 5 is great. The equivalent of 5 out of 5 is this is the best possible freelancer that I could have matched with. And so sort of the intuition behind this and our hypothesis in this experiment was that this client can still give the freelancer an high absolute rating. So, 2 out of 5 is still labeling the freelancer as good. But at a relative scale, sort of 2 out of 5 is fairly bad in that, like in a regular platform, no one's getting these types of ratings. And so the idea is that maybe this allows the client to give poorer relative ratings while still not feeling bad about themselves. And then the rest of the treatments were basically variations on the same theme. So we had, how does this freelancer compare to your expectations or compare to average? And then we positive skewed the results. And then we also had a few other variations, like randomizing the order choice and things like that, in order to just see what the comparative effect was. Okay, so before I get to the results of the rating distribution that we saw, I think it's worthwhile to think about, in an experiment like this, what is the ideal measurement that we could ever do? So I'm going to argue that the ideal, sort of like the best measurement we could do is measure a joint distribution between the ratings that people receive and conditional on the true quality of the freelancer. So this conditional distribution. And so, for example, if the freelancer is like amongst the best on the platform, then how often do they receive 5s? How often do they receive 4s, and so on? Or if they're amongst the worst on the platform, how often? Hopefully, they receive 5s less often. And so, in the theoretical part of the paper that I'll come to in a little bit, we actually assume that we've measured something like this, and then we show how do we actually condense this entire joint distribution into a statistic that you can rank different rating scales on. Now, of course, a big challenge here is that we don't have access to the true qualities of freelancers on the platform. In fact, one of the premises of the paper is that platforms have fairly poor rating systems in the status quo, and so don't actually have good access to true quality data. And so the theoretical part, so to apply the theory part of the paper, we have to have various ways to estimate this data, and I'll sort of get into that a little bit. Before I do that, I hope to just convince you that the rating system design had quite a strong impact, and I think I can do that with a few more naive measurements. So the first naive measurement is, okay, let's just look at the marginal rating distribution. How often are freelancers getting 5s, 4s, 3s, and so on? With the pseudo control of the additional numeric question, we get exactly what you would expect having read the online ratings literature. You get about 80% of people are getting 5s, and there's a very slight J curve where there's another small peak at 0, and then it goes some more at 4s, and so on. With all the verbal scales, however, we see that there's a drastic shift to people getting lower ratings or lower relative ratings. Less than 36% across all the verbal treatment scales were 5s. And so we can already see that we're probably getting some additional information and that at least getting more dispersed ratings. Now, of course, something like this is perfectly consistent with no additional information. So for example, if let's say the clients weren't actually reading the question and were sort of just clicking at random, then you would also still get a highly dispersed rating distribution. So I've shown you that so far we get deflated ratings, but I haven't yet shown you that we get more informative ratings that is actually meaningful to the platform. Okay, so let's try another semi-naive measurement. And so for this, what I do is I take advantage of the fact that on this platform, clients tend to rehire the same freelancer at a fairly high frequency. And so what I'm going to show you is conditional on the first rating the client gave the freelancer during the test period. How often does that client end up rehiring the freelancer for another job during the test? And so what we see actually is that the ratings are quite informative and that the verbal ratings are quite more informative in numeric scale. So this plot, there's a lot going on, so I'll just try to sort of quickly summarize what this is. And so if you look at what's going on at this red box that's highlighted, we see that if a client gave a freelancer a 5 on the numeric scale, that means they're about 20% more likely than the average client-freelancer pair to be rehired by the client for another job during the experimental period. Using the verbal scale, though, however, you're 40 to 60% more likely than the average freelancer to be rehired. And so we see that getting a 5 on a verbal scale, it makes it's far more informative to the platform about these rehires. Okay, so sort of as a checkpoint of where we are, I hope I've convinced you that a simple rating scale design change, just adding adjectives to the answer choices of the question, substantially changes the information that you receive from the ratings. And in particular, positive skewing and adding verbal rating scales yield substantially deflated ratings and that are more predictive of whether the freelancer gets rehired during the platform, during the test. And sort of in the paper, we try to do a bunch of robustness checks, thinking about inflation over time during the experiment, but also heterogeneity that might happen on different parts of the platform. Okay, so now let's think about the second portion, is how do we reason about these different distributions and how that affects things that the platform actually cares about. And I hope to answer here what rating scale, so we tested 6 rating scales, which one of them should actually be used and deployed by the platform? And how should the choices that a rater gives be numerically aggregated in forming a freelancer score? And so our high-level approach is going to be, let's suppose for now that we've estimated this conditional distribution, that we've estimated from an experiment how often a freelancer receives, let's say, a 5 out of 5 as conditioned on their estimated quality, their estimated true quality. And then then we're going to have a stylized model in which sellers are going to accumulate ratings according to this conditional distribution row. The platform is going to estimate a ranking of the freelancers by their empirical rating average. And then sort of this estimated ranking is going to converge to the true ranking. And what we care about is how quickly this estimated ranking converges to the true ranking as it depends on row, as it depends on the conditional distribution. So we're going to have a stylized model to do this, in which we have discrete time k. And we have a mass of sellers that take quality in some discrete set. At each time step, each seller is going to match with some probability that might depend on their quality. So for example, better freelancers might be better at interviewing, so they might get jobs more often, for example. After each match, the seller is going to receive some rating according to the distribution row. And for now, we're going to say that the platform somehow maps that rating to a numeric score. And so naive thing would be to have 5 stars average out to like a numeric 5, 4 stars to a numeric 4, and then so on. But you could also think about non-naive design. So, if a freelancer gets labeled the best possible freelancer at 5 out of 5, but if they get the next possible adjective, it's maybe a 3.6 out of 5 or so on. So the platform is somehow going to choose these scores. And then the seller reputation is just going to be the average of scores that they've received up to that time. And the platform is going to make a ranking of the sellers according to their empirical reputation. And what the platform wants to do is the platform just wants to minimize errors in their ranking. And so there's some ground truth ranking, and they're going to construct, and all you care about is the Kendo-Tau distance between the estimated ranking and the true ranking. In a follow-up paper, we sort of generalize this to any sort of weighted mistake. So maybe bigger mistakes you care about more. But for this paper, we're just going to say that we want to minimize errors in this ranking. So sort of if you stare at this a little bit, you can see that trivially, because of the law of large numbers, for any reasonable design, the error is going to go to 0 as the number of samples goes to infinity. So instead, what we look at is, so it turns out this convergence to 0 is exponential, and it's exponential at a rate that depends on rho. So it depends on this joint distribution on what ratings you're getting conditional on your quality. And that's going to be the exponent in how quickly it goes to 0. I'm not going to go through the derivation of this exponent, but it's a fairly simple large deviations rate of convergence that you can calculate. Sort of the summary is that you can calculate this exponent given a score function, the matching rates, and the rating distribution. And so this is actually what becomes the outcome of your measurement. You can just simply measure and calculate this exponent gamma for a given rating scale from an experiment. And so our approach to choose a rating scale is simple. We're going to estimate rho. We're going to estimate this conditional distribution for each treatment, calculate the learning rates, and then just compare. I'm going to skip how I did the estimation using the data. But if you do that for our online labor market test, we actually do see that the numeric treatment is far less informative, has a far worse learning rate than any of the other treatments. And so it turns out in this test that the average, that one of the treatments in which comparing the freelancers to average actually does the best. Okay, so sort of in the last few seconds that I have, I just want to summarize a takeaway and where, so what we did in this paper is that we showed that in a principled manner, you can design the information that we obtain from people. And what I really hope to do is to turn this into sort of a general framework that for how we can get it, how we get information from people in general. I really think that this is a connection between, you know, HCI and user interface literatures and maybe what we think about in sort of in EC, which is how do we go end to end from just a user interface design to thinking about how that affects various things on the platform. And so we take this approach, and if you follow up papers, then I'm happy to talk about offline. Thank you.